All right, let's start with predicates. So what is a predicate? Now let's say, suppose in this class, we have only 5 students, Allison, Ben, Carlton, Dalton, and Emma, A, B, C, D, E, basically. All right, now consider this statement. Allison is a student in info 2030. How do we form a predicate? A predicate in logic is obtained by removing any nouns or subject from a statement. Of course, there are more than one noun in this statement. Let's begin with easy one. Say, let's remove the proper noun here, Allison. Say, suppose Allison is removed. Okay, suppose Allison is removed from this statement. Then we are gonna form a so-called predicate. We usually denote a predicate by a capital letter, say in this case, a P. And here's what P is. So P is defined as a blank is a student in info 2030. Remember, the proper noun is removed in this case. So we form a predicate. This predicate contains one variable, which is the blank, this blank. And usually when there's a variable, we introduce a symbol, say X, for the blank space. So we're going to write this predicate as P of X, where X represents the variable in this blank. When we substitute this variable only using the people in this class, by the way, this set of people in this class is then called the domain. Then we get different statements. Let's look at the first example. For instance, P of Ben, what does that mean? That means the variable is Ben. Ben is supposed to be filled in this blank. So that means Ben is a student in info 2030. Okay, so that's what P of M means. So you basically just like what we usually do when we have a function. This is actually a function now. So variable is Ben, we plug Ben in here. So is this a true statement or false statement? Because we assume, we have an assumption here. We assume there were 5 students in this class, and Ben is actually a student in this class. So therefore, this is a true statement. So this is a true statement. Now what about P of Carlton? So this means Carlton is a student in this info 2030. Again, is this a true statement? Because we do have a Carlton in this class. So therefore, this is a true statement. Now what about P of Dr. Huang? What does that mean? That means Dr. Huang is a student in info 2030. So is this a true statement? Well, there are only 5 students here. Dr. Huang, is not a student. I'm not a student, and I'm just a teacher, right? I'm just an instructor. So this is false. Dr. Huang is not a student in this class. So this is a false statement. So that's what it is. That's what predicates is. So this is the simplest one. Now let's form another predicate Q by removing one more noun. In this case, the course name, the course. So from the sentence. So therefore, with the original sentence, we are going to remove Allison. We replace that with a blank, and then we are going to remove another one, which is the course name, course number. So we'll replace it with another blank. So therefore, now we get to this point. So blank is a student in blank. Now we actually have 2 variables. So just the same rationale as what we just mentioned earlier, we're going to need two variables for the two blanks. So we're going to denote that by Q of x, y. X is the first one, y is the second one. Okay, so that's what Q of x, y is. Now, suppose we have, oops, a typo here because we introduced the Q. So I'm supposed to change this to Q. So change this to Q. So now, what is Q of Dalton, comma, info 2030? Now, Dalton, which is the first, the value of the first variable should go into the first blank, and the info 2030 should go into the second. So therefore, this becomes Dalton is a student in info 2030. Is this true? By the way, we assume that there is a Dalton in this class. So therefore, this is a true statement. Okay. Now let's take a look at the second example. Well, by the way, I'm teaching Math 0960. There's no student whose name is Ben in my Math 0960. So this is a little background. So now take a look at this Q of Ben, comma, Math 0960. What does that represent? That means Ben is a student in Math 0960. And by the way, I just told you that I don't have a student whose name is Ben in my 0960. So therefore, this is a false statement, right? So, well, I hope that that's with these two examples, you know what a predicate is. So here comes the definition. A predicate is a sentence that contains a finite number of variables and becomes a statement when specific values are substituted for the variables. Like in this case, we have two variables. When specific values are substituted into this predicate, it becomes a sentence, a statement. And the domain is the set of all values that may be substituted in the variable. Okay. Now we are gonna continue to introduce some notations, and we will need those for in the future. We will be using these notations. Z, most of you might already have known it. Z is integer, it represents integers. And when the Z, there's a subscript, that means positive integers. Positive integers. And R means all real numbers, the set of all real numbers. And the Q represents rational numbers. Rational numbers. By the way, sometimes we have C that represents complex numbers. All right, so those are the notation that we're going to use. Let's take a look at a few more examples. So let's define and find the truth set of a predicate. That means we're going to look for the values so that the collection of all the values, which is so-called the truth set, so that a predicate is true. Okay, the truth set of a predicate means the set of all elements of the domain that makes PX true. And here's the notation we're gonna use. So it's a set. First of all, it's a set. So we use curly braces. So X is the elements from the domain such that this vertical bar means such that, or with the property. And what's the property? This guy. So P of X is true. So it's a collection of all the X values so that the predicate is true. For example, let's take a look at, let Pn be, n is a factor of 8. So when we say P of 1, that means, well, again, pause the video whenever you feel like you want to try yourself first. Okay, so I encourage you to try the first. Okay, P of 1 means, according to how we define this predicate, it means 1 is a factor of 8. That means, does 1 divide A is 1, can A be evenly divided by 1? Of course, yes, right? 1 is divisible by 8. I mean, 1 divides 8. So P of 2 means 2 is a factor of 8, okay? And of course, if you say P of 3, that means 3 is a factor of 8, right? So obviously, 1 is a factor of 8, this is true. 2 is a factor of 8, this is true. But 3 is not a factor of 8. So therefore, P3 is not true. 3 should not be in its truth set. 3 is not in the truth set. So therefore, what's the truth set of this P of n? We already know that 1 is a factor of 8. 2 is a factor of 8, 3 is not, 4 is a factor of 8, 8 is also a factor of 8. And some of you may say, well, what about negative 1? Actually, negative 1 is the factor of 8, right? Because 8 is equal to negative 1 times negative 8. So therefore, negative 1 is a factor of 8. So to list all the factors, we have to consider both positive and negative. Therefore, this is the truth set of P of n in this case. All right, let's continue. Let's say, let D, which is the domain, be all teachers at MCC. So you only consider all the teachers at MCC. You don't consider teachers at UNO. You don't consider teachers from Creighton and so on and so forth. Only the teachers at MCC. And define P of X as X is teaching info 2030. Okay, now, suppose we are talking about, say, suppose I do know that in current quarter, I am the only one who is teaching info 2030. However, a group of 4 may be teaching this info 2030. They are like me, Dr. Huan, and Miss Olson, and Mr. Lee, and Mr. Say. Okay, actually, there are 4 people who will be who are teaching the info 2030. So I would say this would be my truth set. If you want to argue, let's just look at currently, then I will agree with you. Me will be the only one who is teaching, but so just try to make the points that whoever will be teaching that or is teaching that, that will be the truth, right? So maybe I'll just make it more general. So 4 people here. So this will be the truth set of these predicates. Now let's take a look at P of X, Y, Z. Now we do have 3 variables here. 3 variables, x squared plus y squared equals z squared. And what's the truth set of P of X, Y, 1? So here the z is actually 1. Now, in other words, this actually is for this x squared plus y squared equals z squared, which is 1 squared, which is just 1, right? So now, what's the truth set of this particular one? If you are not very rusty in algebra, you do know that this actually represents a unit circle, and then all the points on the circle, any points on the circle would be a solution, would satisfy this particular equation. So there are infinitely many points. Now, how do you represent this result? We are going to use a so-called set builder notation. First of all, curly braces represents a set. In the future, we'll talk about that. And then we have, because Z is already known, we are only looking for the X and Y. So I'll just a order pair X and Y. And the the vertical bar means this order pair has the following property. So such that, what's the property that X, Y have to satisfy? X squared plus Y squared equals 1, where X and Y, they are real numbers, right? They're real numbers. So that's how I would represent the truth set of this predicate.